Hi, my name is Hashim Khan, and in this video we are going to explore the kinetics of transesterification of soybean oil in order to size CSTR, which stands for a constant stirred tank reactor. So essentially this was part of my final year design project in which I chose to design a CSTR that converted waste vegetable oil, which is specified to be soybean oil, using the process of transesterification. So here I found this paper which explains the mechanism, the kinetics of uh, this transesterification reaction. So what you want to look for here is these reactions. Anybody studying biodiesel would know that essentially the triglyceride is broken down into the methylated esters in three relevant steps. First, it's broken down into diglycerides and then monoglycerides into glycerol and fatty acid methylated esters. So once you have that, you ought to look for these equations, or you can develop these yourselves if you have the relevant taken the relevant courses in chemical reaction engineering. After you have gone through these, you ought to know the value of the specific rate constants given here, these rate constants. This information will allow us to code a program, to code a script file in Matlab that will essentially give us the volume of a constant state tank reactor. After we get the volume, we can then add the agitator using very simple arithmetics. So let us begin. Now we're going to write the code that is actually going us to give the volume of the CSTR. So as you've seen that the equations that I showed you are ordinary differential equations. Here these are ordinary differential equations in which the concentration of triglyceride or oil is changing with respect to single variable time. We will now code these equations into Matlab. So as you know, if you have any experience with Matlab, you will know that in order to solve different ordinary differential equations, we usually use functions. So we will simply write function CSTR design, and then you would want to leave bracket here. After this, as a comment, add in the function's primary purpose. So the purpose of our function in a very crude way is to size the CSTR. Now after that, simply add these two commands. These essentially clear out the command window and the workspace. Now add another function, but first indent, name it in a different way, and add in. For now, don't be worried if you don't understand anything. Things will become clear in a moment. Now here I want you to add the volumetric flow. Add in any number, 1.3. Now after this, I want you to add the monoflow rate of alcohol. I suppose it's 3, and the molar flow rate of glycerol. Let's say, let's call it G, simple. It's a very good practice to add in the units. So the purpose of adding these is to essentially calculate the concentration of flowing alcohol, which equals and the concentration of glycerol. Now add in the specific rate constants that were shown in the paper. Here they are. Add in these and preferably these ones. These ones. These are the ones you would want to add in your code. Now comes the most crucial part of this script. Now we're going to actually add the equations into our code. So you are to listen to this part very carefully or watch this part very carefully, because once you learn this you can apply it to any other kinetic reactions that you actually have. So what you do is essentially you take this equation and name the parameters that you have not defined as C1, one in the bracket, C1 for this, and write it down on your notebook or someplace. Now, in all the other equations that you will write, this triglyceride will be written as C1, C1, C1. The diglyceride, it will be written as C2, 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 and so on. Simple. Also, now comes the alcohol. We have already defined the concentration of alcohol, so we will write it as it is instead of saying C3 or C4. We will name C3 monoglyceride. This will be our C3, and this will be our C4. Glycerol and alcohol have already been defined. You can name the equation any generic name, but again, you have to differentiate this equation from this equation by writing one or two in brackets. So let's see. Here we write now comes the important part. We write minus K1 multiplied by triglyceride, which is, as we've said, C1. You can call it C2 too, but then you will have to write it as C2 in all the other equations that you are going to write in this script file. Now comes this. As we've already defined here, the concentration of alcohol or any very defined constant that you have in your kinetics program, you have to write it as it is, Ca. Now, same goes for this. We're going to define our triglyceride as C2, as I've already said. And again, we have the concentration as Ca for alcohol. So here are our four equations. Don't worry for now, this is not the complete program. I will do a video on that too. This program is just meant to give you an understanding of how a kinetics program can be written in Matlab environment. The complete code solves the volume and gives volume for two reactors that are in series. This one, however, does only one. But it gives you the idea, it gives you the complete idea of how I wrote this kinetics program. Now, as we've written these equations, we now give MATLAB the command to calculate the volume for our reactor. The volume for a CSTR is given here, where the volume equals the molar flow rate of the species that is reacting. In our case, this is triglyceride, triglyceride or oil. This X stands for conversion, which is very is given in our paper. It's given in this paper. It's 99%. And this again is the rate of reaction for triglyceride. So we're going to be following this equation, this equation here. We're going to write this down in MATLAB. So essentially, V equals flow rate of oil, which was, we have not defined it here, but we can define it. We call it FTG is equal to 1.3. Again, the units are here. Multiplied by conversion, which is 99%, divided by the rate of reaction for oil. This is the important step. So if we see our reactions, we will find that this is what we want to put, this here. We have defined this as dc underscore dt bracket 1. You can simply copy paste it too. Now we have to give the command that displays V. Meanwhile, we also have to append all these in one equation. We do this by making a matrix out of it. Now we simply end two functions. but the program is yet not complete. Please check these values here as I've changed them. So as you can see, there is a red line beneath CSTR, and it says that the function CSTR might be unused. This is because we haven't applied it in the algorithm which solves it. In order to do that, we must write the following line. This is the line. This line gives the directives that the variables t and c are going to be solved using the ordinary differential equation 45 algorithm, which is essentially Runge-Kutta. This is our function. As you can see, it corresponds to this. This is our time. This is our time. It's essentially 1 hour, 0 to 1, 1 hour. And we know that 1 hour has 60 minutes. So this is the difference. These are the different variation levels. This C corresponds to concentrations. These C1, C2, C3, and C4. We essentially know that the concentration of diglyceride, of monoglyceride, and of fatty acid methylated esters is 0 at the start of the reaction. But the triglyceride still has some value. In order to find this value, you can simply divide the molar flow rate of oil with the total flow rate, volumetric flow rate. This will give you the concentration of oil. So if you have the material balance, you can find this value easily, or give it an arbitrary value that makes some sense. As you can see here, that both these have red lines under them. This is because their values are also unused. What their purpose is essentially to graph the kinetics. We can do that by simply giving it the directives to graph. If we run this, so essentially there are two very fundamental mistakes that we are making here. We first name the second function here as now perhaps we can run our program, and voila, we have our program. I'm not saying that this is the perfect, but this is a starter, and mastering this probably will help you in your kinetic studies. So I will roll out newer videos that will explain in detail the full program sometime in the future. But for now, um, please be happy with this. So if you can notice, our graph does not have any axis titles or y-axis titles, or any indication of as to which line is which. We can do that by adding a very simple line of codes. These are in the X label we have time, Y label we have concentration. And this is the legend that explains what the color line means. So here you have your graph.